Language plays a central role in our lives. Just imagine how hard it would be to communicate in a world without language. In this video, we'll take a closer look at how our brains process language. Many important discoveries about language and the brain were made by studying patients with aphasia. The term aphasia comes from Greek and literally means without speech. Patients with aphasia can develop various language problems as a result of brain damage. We'll find out more about these language problems in a minute. Our story begins in the 19th century in France, where the Dr. Marc Dux discovered an interesting pattern. Patients who had lost the ability to speak typically had brain damage in the left hemisphere. He therefore concluded that the left hemisphere is dominant for language, meaning that most language processing happens in this hemisphere. We now know that this indeed holds for most people. Research has shown that the left hemisphere is dominant for language in 97% of right-handed people and 70% of left-handers. In the remaining people, the right hemisphere is dominant for language, or the work is divided over both hemispheres. Now let's zoom in a bit further on the left hemisphere. In 1861, Paul Broca, a French doctor, treated a patient who had not been able to speak for 21 years. The unfortunate patient received the nickname Ton, because the only thing he could still say was Ton. After Ton's death, Broca investigated his patient's brain. He found a large lesion in the frontal lobe of the left hemisphere and concluded that this lesion had caused his patient's loss of speech. This part of the brain is now called Broca's area, and it is considered to be a key area for language production. Patients with brain damage who have difficulty speaking, but who can comprehend language fairly well, are said to have Broca's aphasia. Not long after Broca's discovery, the German doctor Karl Wernicke discovered another form of aphasia, now known as Wernicke's aphasia. He studied a number of patients who had problems understanding language. Unlike Broca's patients, these people could speak, but what they said did not make sense. Wernicke identified a brain region in the left temporal lobe that is very important for language comprehension. This area is now referred to as Wernicke's area. But Wernicke did not stop there. He also proposed that there should be a direct connection between Broca's and Wernicke's areas, and that damage to this connection should also lead to aphasia. Since then, this connection has indeed been found, and is now known as the arcuate fasciculus. We have come a long way since the days of Broca and Wernicke. Using modern brain imaging techniques, we can actually watch what happens in your brain while you speak or listen, creating a much more detailed picture of how language is processed in the brain. So let's take a closer look at what happens in your brain when you speak. Say you want to tell me something about my favorite animal, the sloth. The first step is to find the right word to express your thought. This happens in the middle part of the temporal lobe. It's a bit like searching a dictionary in your brain. You know the names of many different animals, but you want to talk about this specific hairy animal that likes to hang from tree branches. The next step is to select the sounds to say the word. This happens more towards the back of the brain, in an area located behind your left ear. And finally, you need to articulate the word. Sloth. This involves chunking the sounds together and controlling the muscles in your mouth, jaws and throat that allow you to speak. As you can see, many parts of your brain beyond Broca's area contribute to speaking. And this whole process, going from a thought to pronouncing the word, takes only just over half a second. And let's not forget that in normal conversations you use sentences rather than words, and switch quickly between speaking and listening, making your brain's job all the more complicated. So perhaps the most amazing thing about speaking is how effortless it all seems. Many parts of your brain have to work together in a fraction of a second, and you never even notice. So the next time you talk to someone, take a second to admire your incredible babbling brain. And if you want to find out more about language and the brain, check out the links at the end of this video.